Alright guys, welcome back to the channel. Alright, today we're going to continue on with our physics series, and we're going to start by explaining and deriving these kinematics equations. So these kinematics equations are useful when you have a constant acceleration, and they're a powerful problem-solving tool. So like what we said in the previous videos, we defined the definitions for acceleration and velocity, and we're going to use those to derive these equations. So we have A equals change in velocity over change in time. So we can derive the first kinematics equation from this. So change in velocity just simply means final velocity minus initial velocity. So we can rewrite this as A equals VF minus VI over the change in time. And then we do some simple algebra. We multiply by delta t. So we have A delta t equals VF minus VI. And then we can add the initial velocity, and we get the first kinematics equation. VF equals VI plus A delta t. So this is our first kinematics equation right here. Now, let me just rewrite that over here so we don't forget. VF equals A. Alright, that's horrible. A delta t. This is number 1. Alright, now we're going to do the second kinematics equation, which we use our definition for average velocity. So V bar, this was average acceleration as well, forgot to mention, equals change in displacement over change in time. So going back to like basic math class, when you have an average of something, it's the sum of the numbers on the top over the amount. So we have two velocities, we have the initial and the final. So VF plus VI, and so there's two of them, so we do that over 2. And then it's equivalent to the statement, it stays the same. So now what we can do is solve for a delta x to get the second kinematics equation. So we have delta x is equivalent to VF plus VI over 2 times the change in time. So now we have 2 of the kinematics equations. There are 4 of them. Alright, so now that we have these 2 equations, we can derive the other 2 equations using these 2 variables. So I see that we have a final velocity in this equation, and we already have an expression for final velocity, so let's just sub this equation into right here. So we're going to have delta x equals VF, which is just VI plus A delta t, so we can replace that. VI plus A delta t, and then we're going to add this to the initial velocity. This is all over 2 multiplied by delta t. So now we just do some simple algebra, some simple algebra, and then simplify the expression, and we will get this. Add the VI's, so it's going to be 2 VI plus A delta t over 2 t. Since there's only one thing on the bottom, we can split the fraction, and we get delta x is equivalent to 2 VI over 2 plus A delta t over 2 times change in time. And then we can get the third kinematics equation, which is initial velocity, actually not yet, plus 1/2 A delta t. And then finally, the third kinematics equation, which is this. So this is number 3. So we have change in x is equal to VIT plus 1/2 A delta t squared. So we have 3 equations so far, and then we're just going to derive the 4th and final equation here. It's a similar process to how we got the 3rd equation. We're going to use these 2 equations once again to derive the 4th and final kinematics equation, the special timeless equation. So let's start with the 2nd equation. We have delta x equals VF plus VI over 2 times change in time. So let's rearrange for time. Delta t equals delta x over VF plus VI over 2. And then we keep change flip, and then delta t equals 2 delta x over VF plus VI. Now we see that we have delta t, we have a new expression for that, and in the first kinematics equation that we found, we also have a delta t. So what I'm going to do is substitute this value in for over here, and we will get the 4th equation. So let's do that. So VF equals VI plus A, and it was 2 delta x over VF plus VI. Now we're just going to solve, do some algebra. So we have VF minus VI equals A times 2 delta x over VF plus VI. And then what we're going to do is multiply by VF plus VI. So it's going to be this. VF minus VI multiplied by VF plus VI. This is equivalent to A 2 delta x. Or I should just rewrite it like 2. Like this. 2A delta x. Okay, so this here is these 2 are conjugates, so what you can do is if you want to multiply them out you can, or it will just be equivalent to VF squared minus VI squared and then equals 2A delta x, and then we just add over and we have the 4th and final kinematics equation, the timeless equation, where it is VF squared equals VI squared plus 2A delta x. Alright, there we have it. This is number 4. Those are your 4 main kinematics equations, and in the next video I'll show you guys how we can use these to do some simple motion problems that will probably that are very common in physics classes. Thank you guys for watching. Smash subscribe.